slots. We have already defined bus inline in our lessons early, but let's formally define it. A bus is a communication system that transfers data between system components. And you know physically that's going to involve traffic of electrical pulses. That's how those binary zeros and ones. The data gets shuttled from component to component. Either there's a voltage on one of those traces or there is not. If there is no voltage, that equals binary zero, and that gets stored in memory or on the hard disk or in the processor cache. If there is a voltage, that translated into a binary one, and then from there, once you have what's called that bit stream, you can form words, literally words that deal or are processed by your operation system and device drivers in the application that you use. Bus speed, like I said, we don't need to be concerned about memorizing numbers here. Instead, I want you to identify the names and the shapes and the basic operations of these motherboard components, because remember, as we walk through this course, we're going to spend an entire module on each component specifically. So if you're into the numbers, that's cool, but let's take it slowly. Okay, now when we talk about buses, you come across the term parallel and serial, specifically when we talk about the expansion buses like PCI and PCIe. PCIe stands for Peripheral Component Interconnect. It's example of what you see down below. That's what a typical old school expansion slot looks like. The card has copper contacts on it, and you line up the contacts of the card with the contacts on this slot, and you press it into place. And then you screw down the upper lip or edge of the card to the chassis to secure it. And you got yourself some expansion. That expansion can be a network interface, it could be a sound card or a graphics card. The whole idea is that you can custom fit the purpose of a computer by using expansion slots. Notice that the connectors in the slot will oftentimes have a K or a notch in them. This notch does a couple different things. In some cards, it can designate particular voltages, and it can therefore prevent you from burning out a motherboard by inserting a card that operates at higher power level than another one. Another reason for the K, very simple, is to prevent you from putting the wrong kind of cards into the expansion slot. Now, I mentioned conventionally or old school PCI here, even though it's not exactly a dead technology, but certainly a legacy one, because you will still find it even on current motherboards. It operates pretty slowly, 133 megabits per second at 32 bits and 33 millionths instruction per second. Instruction per second or cycle is normally given in megahertz or millions of cycles per second or gigahertz, billions of instruction per second. And speed over on the left, when we talk about bus architecture, will normally be in megabytes per second. And as a reference for size, think that an MP3 audio file weighs in around 5 megabytes. The old school PCI can do 64-bit addressing, and when you think about 32-byte or 64-byte addressing, that deals with how big of a number bus is capable of sending out in one clock cycle. So if you think that 64-bit is double 32-bit, you're absolutely right. That having been said, conventionally PCI uses parallel communication, which we will look at it in a slide in just a moment. That tends to be slower than serial communication. PCI Express is the replacement for conventional PCI. If you go shopping for a new graphics card, for instance, you're going to actually have a hard time finding an old conventional PCI card, and you might get an unpleasant surprise when you open your computer chassis and see that you don't have any conventional PCIs. PCI Express or PCIe is the current standard, and depending upon the interface, we're talking about potentially huge data transfers. PCI Express, the slowest speed model, is what's called by 1 card or X1 card by 1, and that refers to the number of data lanes that card is able to use when it's shuttling data. That's 215 megabytes per second. You can see that even at its lowest speed, PCI Express is almost faster than PCI. The current standard is by 16, and there we are talking about gigabytes per second. Very, very fast. See you next time.